So if we are going to calculate pi, we must follow this flow chart, which will help us to find this pi. So first we have this flow chart, and we will ask user to enter the dots, number of dots, because we are going to estimate with dots, and initialize, because before we began the process, inside the circle will be 0 dots, and we generate those random numbers if it is 1000 or 100 or whatever, depending on what the sample we want, the size of the sample we want to use. So here we check the distance from the radius if the dots is inside, and if it is inside, then we will store it in here in this initial dots in the circle, and now it will be 1. If we find another, it will be 2 dots or 3, like this, or etc. And if it is not, it will not be inside the circle, so we continue checking also. Here we increment the dots here in circle by 1, and after all the process of these random numbers, we do the calculation of pi. So how to do calculation of pi? It will be like this. Here maybe I have a document here. Okay. Okay. For now, we are going to see how you can approximate pi mathematically, because as we've seen how we'll be doing it, here we have the circle and the square, and inside the square or the circle, we have the dots that we are going to use to approximate our pi. And you see that here the radius equal to 1, and for you the radius can be equal to anything that you want, be 2 or 3 depending on what you want. And the x, it will be like two radius, because you see here it will be 1 and here 1, so it will be two radius, 2 times r. So we know the area of circle, which is pr square, and I know that is 1, then it will be equal to p. And the area of square is x squared, and x we find that is equal to 2r, and r is 1, then it is 2 squared, which will be equal to 4. So the area of square, because it has 4 over 4, is equal to area of circle, which is equal to pi over pi proportions. And pi, denominator, pi times area of square equal 4 times area of circle, which pi will equal to 4 times area of circle over area of square. So here we use, because it is 4 times the dots which are here inside this circle, here, the dots that will be here, and over the dots, all the dots, because the dots that will be here, even also the dots that are inside the square plus the outside of the circle. So this is Monte Carlo simulation technique, and here I've tried here there are points I entered there 19, and 11 of them are inside the circle and others inside and 19 are inside the square. So I have to do 4 times 11 over 19, which is equal to 2.31, which is not a better approximation of pi. So based on all of this information, it is almost easy to find pi using Python. So how we are going to do it is that we use yeah. Yeah, here you see that this is the Python we do it. So I have here the code already written because it takes long process. First, we need to know import random, the random values that we'll be using. So we can also import map so that we can see if our approximation and the real value of pi are so close to conclude that we are doing better. You can ignore this because it's about plotting and drawing graphs. We do it later. And here you see all the dots that we'll be using, the sample size that we'll be using of dots. This is the dots that will be inside the square, the circle, before we start our process of flowing those dots inside the square and see how many dots are inside the circle or how many dots are inside the square. Here we can ignore radius will be equal to 1, and we are going to check for every single dot inside. We fill inside this square. If some will be in circle and others will be in the square. So we are going to do this. X, so random here. If X will go to random dot uniform between minus radius, because circle is minus radius and radius, and also Y. And we check so that we can find the distance of this. And you see that the distance equal x squared plus y squared is equal to radius squared. But we are checking if this distance will be less or equal to radius squared. Because if it is bigger than radius, then the dots will be outside of the circle. So this will not count to our dots inside the circle. But if it is less than or equal to radius, it means that it will be inside the circle. And for our value here, we initialized for value will be 0. Here we add 1 because this dot is bound, add 1. And we try this all of this loop until the all dots we enter. For example, if we enter 100, it will run 100 checking every single dot if it is in a circle or in the square. So here in the loop, it will go through all of the dots and checking if it is in the square or not. And if it is in the circle, if it is in the circle, it will add to this value. Those inside circle will be 1 now. And if I run again, it will be also another 1, which will be equal to 2. So if I find that I have now dots inside the circle that I found. So pi will be 4 dots circle over trial numbers. Those single numbers we found here, if it is 100, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dots. So yeah, will be like 4 times dots inside circle over total trial numbers, which will be all the numbers. Here, all the numbers. Approximation of pi will be this one. That's how we find our pi. Because if we do this at 0, and for for those in range 1 and all dots, yeah, all dots x equal to 100 dot uniform minus radius and radius. And also y will be equal to this, will be equal to this. Radius should be equal to 1. So if I find this, I will check if x, this is 1, if x squared plus y squared is less than or equal is less or equal to radius squared, then dots inside the square we add 1. Radius we add 1. So here I will equal 4 times dots inside the set over or over dots here, and over dots. Yeah. And here if we print pi is I. If we run this, for example, we enter 100, you see pi will be equal to 4.7. If we run it also like 1000, will be like it is becoming closer to pi. If we run 10,000, 3.12888. So this is the how you can approximate pi using Monte Carlo simulation. You see that the more dots you enter, the best pi gets. You see x y, you have these values was equal to 1. Let me see dots inside circle 7,782, and to see all dot 10,000. You see, if I do 10,000 minus 7,782, 2,218. These are the dots that are not in the circle. And it's pretty good, and you can optimize it until you find the value of I. Yeah, this is how you can simulate it.